All right, so now what we're going to do is we're going to look at two different methods to kind of really find that um, least common denominator or least common multiple. All right, so least common multiple, the multiples of a number d are basically just 1 times d, 2 times d, 3 times d, 4 times d, and so on. And so basically we're taking the number times, 1, 2, 3, 4, 5. So the LCM between two numbers is the smallest multiple of the numbers that actually matches. And we'll see what we're talking about here in a little bit. So that's the first method. And so we list all the multiples of each number. There's two numbers, and then, hey, maybe it's here, and we had to multiply clear out here, and those two are the least common multiple, okay? And so then the smallest multiple that matches is the LCM. Now, prime factors is the other way, and we've been doing prime factors already because, those are actually easier. And so we find the prime factorization of each number, then we use the prime numbers, and most times it is used in one factorization for either denominator. All right, so what we're going to do is we're going to find the least common multiple, and we're going to do both methods, method 1 and method 2. All right, so what we need to do is for method 1, we have to take, we have a D, and then we have a 2D, and then a 3D, and a 4D. We're just multiplying by the next number up, and then we see which one matches. So, okay, so 18. So 18 is our first one. Then we're going to take 18 times 2. All right, so we might actually run out of page here because I don't know if I'll have enough room. So 18 times 2, that's 16. So that's 36. All right, maybe let's go down. And so then once the first time we hit it, we'll have the same number. So 24. Well, 24 times 2, that's going to be 8. That's going to be 48. Okay, well, none of them matches yet. So now we have to take 18 times 3. Now, another way to multiply is if we add one more 18. So this was 18 times 2. If we add 18, now we have 6 and 8. That's going to be a 14. That's 3, 4, 5, 54. And so that's going to be our next one. So that'll be 54. Now, if we think about the other one, we had, 24 times 2, that was 48. Now let's just add another 24. Instead of multiplying by 3, let's add. So 8 plus 4, that's going to give us 12, carry 1, 4, 5, 6, 7, 72. All right, so our next one here is 72. All right, now we have to go the next multiple. So we had 1, 2, 3, so we need 4. So we add one more 18. We have 8, 9, 10, 11, 12, 5, 6, 7, so 72. And guess what? We are done. We don't have to do any more because 72 and 72. Now, there was nothing anywhere earlier that matched, but once we hit that 72, it matched. And so we're done at that point. And so our LCM here is, well, not 70, whatever I was going to write there, 72. So that's our LCM. Now, what about the second method? Well, that's just the one we've been doing, So we take and we'll break 18 down, and we'll break down 24. Well, that's going to be 2 and 9. That's 3 and 3. And those are the prime factors, so we're done. All right, what about here? Well, that's 2 and 12. That's 2 and 6. And that's 2 and 3. Okay, so we have 1, 2 here, and we have 1, 2, 3 2s here. So we'll use 3 2s. And so, well, let's write them out here. 2 times 3 times 3. This is 2 times 2 times 2 times 3. And so we have 3 2s, so that's going to be 2 times 2 times 2. And then we have 2 3s here, 1 3 here, so times 3 times 3. Okay, so 2 times 2 is 4, times 2 is 8. Now that's 8 times, well, 3 times 3 is 9. 8 times 9 is 72. Okay, and so that's what we got here. So I personally like to do this because, on these small numbers, yeah, it might actually be faster to do it this way. But if we ever get to big ones, trying to think, okay, well, if we have, 95 and 105, what's the LCM? Then you're going to have to keep going out further and further, and you're going to have a lot of adding, subtracting, multiplying, however you want to look at it. Or, we can just factor, 95 and 105, and boom, 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 we're done. We get our factors, and then we multiply them together again. We get our LCD, okay, or LCM in this case. All right. What about 20 and 12? Well, 20, well, that's going to be 20, 40, 60, 80, and then 100, then 120, then 140, then 160. That one's pretty easy. So I can go out pretty quick on that one. I didn't even have to do any multiplication. Well, what about 12, though? Well, 12, okay, that's 12. Well, times 2, that's going to give us 24. Times 3, that's going to give us 36. Times 4, that's going to give us 48. Times 5, that'll give us 60. Guess what? We found one. Because we were looking for something with a 0 on end, because those were all zeros. So 60 is going to be the LCM, okay, based on method 1. Well, what about method 2? Well, 20 and 12. 12, again, is just 2 and 6, and then that's 2 and 3. So that's going to be 2 times 2 times 3. So that one was, the quick one. Now, 20 is not too slow either, because that's 2 and 10, and then that's 2 and 5. So we have 2, 2, and 5. So our LCM, well, we have 2 2's in each case, so that's the most, times a 3, times a 5. So 2 times 2 is 4, times 3 is 12, times 5 is going to give us 60. And so we get 60, again, no matter which way. Now this one, I think maybe might have been a little quicker with the factoring than it was here, even though this one really wasn't too hard either. We just had to keep adding 12 or adding 20 to each case. Now, what about these? Well, then if we think about that, we have 108, then we have 216, and then it starts getting big. And 72, it's already big. You have to start using actual multiplication before you can do it. So what I'm saying is, once you start getting to bigger numbers, sometimes doing the by the method 1 is a lot harder. And so all I'm suggesting is on method 2, that's easier, because you can break it down into prime factors a lot quicker usually than you can break down or multiply times 2 or times 3 or times 4 or times 5. It starts getting a lot more tedious to multiply by bigger numbers. So 108 and 72. Well, guess what? We can divide that by 2. What's left over? Well, that's going to be 54. Okay, so we have 2. Well, we can divide by 2 again. And we 2 that, and 2 goes in there twice. And then we have 1, 4, 2 goes into 14 7 times, so we have 27. Okay, that's pretty easy. Well, 27, that's just 3 times 9. So that's pretty well done. And then 9 is 3 and 3. So we have on 108, we have 2 times 2 times 3 times 3 times 3. Okay, so that's what we get there. Well, what about 72? Well, that's going to be 2 and 36. That's going to be 2 and 18. That's going to be 2 and 9. And now we have that 3 and 3 again. So we have 3 2's and then 2 3's. 2 times 2 times 2 times 3 times 3. Okay. So what is LCM? Well, it's going to be how we had 3 2's, so 2 times 2 times 2. We had 3 3's, and that's going to be our LCM. And so if we think about that, 2 times 2 times 2, well, that's going to be 8. And 3 times 3 is 9, times 3 is 27. So now we just have to take 27 times 8. So that's 56. And that's going to be, 16 and 2, 1, 216. Okay. And so 216 is going to be our LCM. Now, what would we have to take 72 by to get that? Well, we'd have to take that times 3 before we did it. So we'd have had to do, 2 or 3 factors for 108, and then at least 3 factors for 72 at multiples. And once we did that, then we would find that 216. And here we just had to break it down. And, dividing by 2's is pretty easy. And dividing by 3's is pretty easy. So it's not hard doing that. All right. What about 36 and 24? Again, 36, well, that's going to be 2, and we have 18. 18 is 2 and 9. 9 is 3 and 3. So we have 2 times 2 times 3 times 3. So pretty easy. 24, what do we have here? Well, that's 2 and 12. That's 2 and 6. And that's 2 and 3. So we have 3 2s and 1 3. So we have 3 2s, 2 3s, and that's going to be our LCM. Well, that's going to be 2 times 2 times 2 is 8, times 3 times 3 is 9, and so that's going to be 72. So I would only had to do 2 here, but I wouldn't really know how far to go out unless I did it kind of like we did that first one. Where we just did, each one and each one and each one, and that, might have saved us time. But a lot of times what people do is they'll do 18, 36, 54, 72, next one, next one, next one, next one, and they'll go out like 6 or so, and then they'll do the same thing for the next one. Then they find, oh, I found the first one already, and so they've wasted some time here. So if you're doing it like this, piecemeal, then that method's not too bad. But I think once we hit these bigger numbers, I think it's just easier just to divide and get our prime factorization tree and then go from there. Okay. And so then here, that was our LCM. All right. So let's stop there and then we'll come back in a little bit.